For this video, we are going to solve for the range or the basis of the range specifically and the rank of these two matrices here. To do that, we are going to solve or determine the reduced row echelon forms of both matrices. Why do we use the reduced row echelon forms? It's because after we have identified the reduced row echelon forms, we need to pick the columns that contains leading ones, or we also known as the pivot columns, as these columns are what comprises the column space, which is equal to the basis of the range. So that's a lot of idea. Bottom line, we need to solve for the reduced row echelon form that will help us solve for the basis of the range. The rank, on the other hand, is the dimension of the basis of the range. So still, it's connected to the basis of the range. So let's start with this. Let me copy here 1, 2, -1, 0, 1, and 1. Since this is already a leading one, what we need to do here is to make the other entries on the same column be equal to 0. So we simply add row 1 and row 2 for row 2 to become 0. And we multiply -1 to row 1 plus row 3 to make this entry in row 3 be 0. With that, this is 1, 2. You add row 1 and row 2, that's 0. This is 2. And then -1 times 1 is -1 plus 1, 0. -1 times 2 is -1 plus 1, -1 here. Since the first column is already okay, our goal here is next to make this a leading one by multiplying 1/2 to row 2. So we'll have this form now, 1, 2, 0. The 2 becomes 1. This is 0, -1. Since this is already a leading one, and to make this entire matrix in its reduced row echelon form, we need to make sure that the other entries aside from that leading one, which is 2 and -1, be equal to 0. Hence we can do this. Row 2 plus row 3 for a new row 3 to make this 0, and then -2 times row 2 plus row 1 to make this entry here 0. So you have here, so the middle row is still 0, 1. So if we're going to add 0 and 0 here, that's still 0. 1 plus -1, 0. On the other side, if we're going to multiply this with -2, so this is still 1, it won't change the value. But the other one, -2 times 1 is -1, -2 rather, plus 2 is 0. This is now our reduced row echelon form of our our first matrix. And notice that both columns contain leading ones. Hence, they are both considered to be pivot columns. In our initial matrix, these columns here will now be part of our column space, which is again similar to the basis for the range of T. It's a set containing the two columns 1, -1 and 1, then 2, 0, 1. 1, -1, 1, and 2, 0, and then 1. So we have two elements here. Or you could also rewrite in this manner in vector form 1, -1, 1, and then we have 2, 0, and 1. So these two are both acceptable. Take note that in solving for the basis here, we use here the column space, or the idea of the column space. If you're going to use the idea of the row space, you could also get another basis, but both of them are acceptable. And since we used column space in a previous video, let's just try to continue using the column spaces here. With this, the rank of our matrix here is again the dimension of the basis of your range. Since our range has two elements, the rank of T is also 2. Let's proceed to our second matrix. Let's come up with the reduced row echelon form. This again, let me just copy first. Okay, this is now 0. No need to manipulate that. What we could do is to manipulate this by multiplying -2 to row 1 plus row 3 rather, so that row 3 it becomes 0. So you have here, this is still 1, 0. We have not manipulated the second. So the third would be negative 2 times 1 is negative 2 plus 2, 0. Negative 2 times 0 is 0 plus 1, 1 here. Now, depending on what you do, you could of course multiply negative 1 to our row 2 to make this a leading one. But just in the meantime, let me just interchange row 2 and row 3 so that I have here 1, 0, 0, positive 1, 0, negative 1. So that it'd be easier for me to make this 0 by simply adding row 2 and row 3 for a new row 3. Hence, our matrix here is 1, 0, 0, 1, 0. Add this to 0 as well. So similar to the reduced row echelon form of our first matrix, these two are also considered to be pivot columns, and they comprises for the basis of the range of T, but we'll be using here the columns on our initial matrix. 1, 0, 2, 1, negative 1, and 1. 1, 0, 2, you have your 1, negative 1, and then 1. Close that. Or you could have like this 1, 0, 2, and then 1, negative 1, and then 1. Since there are two elements there, so again the rank is just the dimension of the basis for the range, so it's just equal to 2. These are now the answers for the second matrix. So again, this is how we show the basis of the range and the rank of these two matrices under linear transformation. Thank you very much for watching.